Bismillahirrahmanirrahim. Assalam O Alikum, dear student. Today we will solve new syllabus Physics SSC 1 unit number 8 thermal properties of matter. In exercise 8 numerical problems 8.1 to 8.5. In this chapter, total numerical 8.1 to 8.10. Total 10 numerical. In this video, we can solve 8.1 to 8.5, first 5 numerical, and in next video, we can solve the remaining 5 numerical. So, in numerical number 1, temperature of water in a beaker is 50 Celsius. What is the temperature in Fahrenheit scale? Given temperature scale is Celsius scale. Now we can change the Celsius scale into Fahrenheit scale. First of all, write the given data. Temperature in Celsius scale Tc is equal to 50 Celsius. To find temperature in Fahrenheit scale Tf is equal to question mark. Now, using the formula, temperature in Fahrenheit scale Tf is equal to 1.8 temperature in Celsius scale plus 32. So, for solution, temperature in Fahrenheit scale is equal to 1.8 multiplied by temperature in Celsius scale plus 32. Putting the values, then temperature in Fahrenheit scale is equal to 1.8 into 50 plus 32. 1.8 multiplied by 50 is equal to 90. So 90 plus 32 is equal to 122 Fahrenheit. So the result of this, the required temperature of water in Fahrenheit scale is 122 Fahrenheit. In question number 2, normal human body temperature is 98.6 Fahrenheit. Convert it into Celsius scale and Kelvin scale. Here, given data, temperature in Fahrenheit scale Tf is equal to 98.6 Fahrenheit. Now, we have required the two values, temperature on Celsius scale and temperature in Kelvin scale. Now we using the formula temperature into Celsius scale is equal to 1 upon 8 into temperature in Fahrenheit minus 32 and temperature in Kelvin scale is equal to temperature into Celsius scale plus 273. Now the solution, first we can find temperature in Celsius scale. Temperature in Celsius scale is equal to 1 divided by 1.8 into temperature in Fahrenheit minus 32. Putting the values, then temperature into Celsius scale is equal to 1 divided by 1.8 into 98.6 minus 32. First of all, 98.6 minus 32 is equal to 66.6. Now, 66.6 divided by 1.8 is equal to 37 Fahrenheit. So, the temperature in Celsius scale is equal to 37 Celsius scale or Celsius degree. So, Fahrenheit temperature into Celsius scale is 37. Now we can find secondly temperature into Kelvin scale, then temperature into Celsius scale plus 273. We have 3 273 plus 37 is equal to 310. So the temperature in Kelvin scale 310 Kelvin. Now in question number 3, calculate the increase in length of aluminium bar 2 meter long when heated from 0 Celsius to 20 Celsius. If The thermal coefficient of linear thermal expansion is 2.5 multiplied by 10 raised to power minus 5 per Kelvin. So first of all, write the given data. Initial length is equal to L naught is equal to 2 meters and initial temperature T naught is equal to 0 Celsius. Now 0 Celsius change into Kelvin, then added with 273. So 0 plus 273 is equal to 273 Kelvin and final temperature T is equal to 20 Celsius. Now change the 20 Celsius into Kelvin. So 20 plus 273. Then 20 plus 273 is equal to 293 Kelvin. And the temperature change in temperature is equal to delta T. Delta T is equal to final temperature minus initial temperature. So 293 minus 273 is equal to 20 Kelvin. Now the coefficient of linear thermal expansion, it is denoted by alpha, so is equal to 2.5 multiplied by 10 raised to power minus 5 per Kelvin. So to find the increase in length delta L, using the formula L is equal to L naught into 1 plus alpha delta T. So we have firstly find the length, change in length or final length at 20 Celsius. So L is equal to L naught into 1 plus alpha delta T. Putting the values, L naught is equal to 2 into 1 plus 2.5 multiplied by 10 raised to power minus 5 multiplied by delta T 20. Now multiplying the values, then 2.5 multiplied by 20 is equal to 50. So L is equal to 2 into 1 plus 50 multiplied by 10 raised to power minus 5. Then 50 multiplied by 10 raised to power minus 5 is equal to 2 into 1 plus 0.0005. Then 1 plus 0 0.0005 is equal to 1.0005. Then 2 multiplied by 1.0005 is equal to 2.001 meter. Now we can find the change in length or increase length. Then delta L is equal to L minus L naught. This will be equal to 2.001 minus 2 is equal to 0.001 meter. So 0.001 meter change into centimeter multiplied by 100. Then this answer will be equal to 0.1 centimeter. Now in question number 4, a balloon contains 1.2 meter cube air at 50 Celsius. Find the volume at 40 Celsius. Thermal coefficient of volume expansion of air is 3.67 multiplied by 10 raised to power minus 3 per Kelvin. Now, first of all, write the given data. Initial volume V naught is equal to 1.2 per meter cube and initial temperature T naught is equal to 15 Celsius. 15 Celsius change into Kelvin, then 15 plus 273 is equal to 288 Kelvin. Now we can write the final temperature T is equal to 40 Celsius. Then 40 plus 273 is equal to 313 Kelvin. Now find the change in temperature. Change in temperature is denoted by delta T and delta T is equal to final temperature minus initial temperature. So 313 minus 288 is equal to 25 Kelvin. Now coefficient of volume expansion beta is equal to 3.67 multiplied by 10 raised to power minus 3 per Kelvin. Now we have to find the final volume V. So we using the formula V is equal to V naught into 1 plus beta delta T. For solution putting the values, then V is equal to 1.2 into 1 plus 3.67 multiplied by 10 raised to power minus 3 plus delta T 25. First of all, 3.67 multiplied by 25 is equal to 1.2 into 1 plus 91.75 multiplied by 10 raised to power minus 3. So we can written that 91.75 multiplied by 10 raised to power minus 3 is equal to 0.09175. So V is equal to 1.2 into 1 plus 0.09175. Then added 1 plus 0.09175 is equal to 1.2 into 1.09175. So 1.2 multiplied by 1.09175 is equal to 1.3 meter cube. In fifth numerical, given statement, how much heat is required to increase the temperature of 0.5 kg of water from 10 Celsius to 65 Celsius. First of all, write the given data. Mass of water M is equal to 0.5 kg and specific heat constant of water, it will also constant is equal to 4200 joule per kg per Kelvin, and initial temperature T1 is equal to 10 Celsius is equal to 10 plus 273. 10 plus 273 is equal to 283 Kelvin. Final temperature T2 is equal to 65 Celsius. So 65 plus 273 is equal to 388 Kelvin. Now the change in temperature delta T is equal to final temperature minus initial temperature. Then 338 minus 283 is equal to 55 Kelvin. Now we can find the amount of heat is equal to delta Q. Using the formula delta Q is equal to mc delta T. For solution, putting the values delta Q is equal to mc delta T is equal to 0.5 multiplied by 4200 multiplied by 55. So multiplying the values, then final answer is 115500 joule. In next lesson with remaining numerical, best of luck.